All right. Thank you again, everyone, for coming out. My name's Dave Haney with Barton and LaJudas Engineers. This is our second public meeting. As Joan mentioned, we'll have a third public meeting towards the end of August. We'll have some more details about that in a moment. I just want to let everyone know that this is being recorded, just the presentation and the discussion. So this will be posted to the foundation's website at the conclusion of the presentation. So I just want to introduce our team. Again, I'm Dave Haney with Barton and LaJudas Engineers. To my left, I have Liz Moran with Anchor QEA and Dave Matthews with Upstate Freshwater Institute. And Monica is in the back also with Upstate Freshwater Institute. But we also have a lot of additional stakeholders. All of you here, the community is probably the most important part of our project team. So thank you for coming out today. For those of you on Zoom, thank you for joining. But we have a lot of other stakeholders as well. We've got folks from the state, from PRISM, who is a repository and information exchange for invasive species. We also have the New York State Department of Environmental Conservation. In the back, we have Karen Hansen and her colleague, Helen Planko. Thank you very much for coming out today. The New York State DEC is ultimately the agency that will review this 9-element plan and approve it. So thank you again for coming out today. We have the Citizens Statewide Lake Assessment Program, CSLAP. Those are volunteers. Some of you here are volunteers with that collect water quality data within the reservoir. And Dave Matthews is going to speak a little bit later about some of the data and some of the trends that we're observing within the reservoir. Also on the state side, we have the Department of State, New York State DOS, which is a potential funding source for future implementation. We have land trust. We have highway departments. We're going to talk about a lot of roadside maintenance, stream bank maintenance. So we'll be bringing in not only the local town highway departments, but also the county highway departments as well for input. We've got Cornell Cooperative Extension, and then we've got Madison County, a little bit, of course, in Onondaga County, but at the county levels, we have the Soil and Water Conservation District, Department of Health, and Departments of Planning and Economic Development. So a lot of interest and voices go into development of this plan. So just what we're going to walk through this afternoon. Joan gave the welcome and introductions. Liz is going to give an overview of what a 9-element plan is. And then we're going to spend most of the time today talking about what we've done so far, our progress to date. I know a lot of you went to the foundation's website and went on to the survey and went on to the interactive mapper. We've got a lot of good feedback, and I'm going to go over the results of that feedback and then talk about where we're going and what the vision is for the reservoir and what the opportunities are for improvement. And I really look at that as a discussion because we're not there yet as far as development of the plan. That's where we're really looking for your input. And then we'll talk about next steps as we work through the summer and develop a final draft plan towards the end of August. So with that, I'm going to turn it over to Liz, give an overview of the 9-element framework.
Okay, thank you everyone for joining us today. I am going to talk about the 9-element plan framework, as Dave said, what we're doing, the progress we've made, and how it all fits together into the long-term management of this DeRuyter reservoir. So in general, watershed planning is like any kind of community planning effort, right? You try to answer these basic 4 questions that you see up here on the screen. You know, where are we now? So that's the current conditions, descriptive information, community values, kind of just what is unique about this system and the people who are living, working, and recreating within this lake and its watershed. The second question, where are we going? So what do we see as trends? Are you having trouble hearing me?
I can hardly hear you.
That's just for the Zoom. That's just for the Zoom.
Okay.
So
All right, so I should just speak up more. Thank you. I will do that. So where are we going? You know, what are the trends? Let's look at data about the reservoir and try to discern what factors are changing, which ones are under local control maybe, and which ones might be more impact of kind of regional change, like climate or precipitation patterns changes, invasive species. So that's question number 2. Then question number 3 goes back to what Dave alluded to, which is what's the vision? You know, if you leave this watershed and come back in 20 years, how would you describe DeRuyter Reservoir and its watershed? What are the qualities that mean most to the community? So we tried to get at that through discussions with the Preservation Foundation, and we've come up with a vision statement that you'll see toward the end of, that's in Dave's part of the presentation, right? And then as Dave said, the focus of this meeting and why we really hope to have some good discussion is okay, knowing where we are and where we're going and where we want to be, what's that 4th question? How do we get there? So what specific actions, priorities can be taken to really move us toward that desired future? So those are specific agendas. And as you'll see, when we talk about what's different about 9-element plans is we have a quantitative tools that help us make those assessments of what are the actions and the recommendations that will move us toward that desired future. Okay, so watershed planning isn't new. It's been around, I kind of date it to the beginning of the Clean Water Act. So 50 years ago, last year, the Clean Water Act was signed into law. And what it does is look at what are the sources of pollution to our nation's waters and what can be done to help that. So once that kind of assessment and kind of mindset was developed, there was a lot of effort on understanding what we call point sources, which is discharges from things like wastewater treatment plants or factories that move through pipes into waterways. But then there was a growing realization that what's running off from the landscape, carried in by rainwater and snow melt from either farm fields or developed areas, that they're also delivering contaminants, pollutants to our waterways. And that's kind of coined a new phrase of non-point sources. So that means that even reservoirs like DeRuyter that are isolated, there's no wastewater treatment plant pipes going into the reservoir, there's no factories on the shoreline discharging. Even those reservoirs then are affected by what's washing in from the landscape. And so that kind of opened up a whole new field of study and investigation and a universe called best management practices. So knowing what we know about the nature of the landscape and how human activities affect that, what can we do better? How do we keep more of the pollutants and materials, sediment, phosphorus, nutrients on the landscape and not running into our waterways where they can have some undesirable impacts? So as you see here, this one, the traditional watershed management planning, all based on this, you know, best available science, community-driven priorities, a public process, because of course, in New York, land use decisions rest with the local communities. So there's no external, you know, county laws or state laws that govern agriculture or how much paving can go onto a particular area of land, something we call impervious surfaces, things that affect runoff. There's no kind of overarching regulatory authority to guide that. That rests locally, and it's kind of relies on voluntary compliance, community education, local laws that are, built on trust and understanding as well as in enforcement. And then finally, I have on this list commitment to adaptive management, which is, and you'll see this in our 9-element plan quite a bit. This is understanding that things change. The landscape changes, the weather changes, development changes, lots of things get altered over time. So we need to keep measuring how effective our approaches are and if we need to do more to reach that desired future. So that's kind of the adaptive management. And now what makes a 9-element plan unique and why this plan for Girida Reservoir builds on the existing watershed management plan that was done in 2018. It's based on a framework that was developed by EPA and has now been embraced by New York State DEC to take a quantitative approach to looking at these relationships between what's happening on the landscape and what's running into the waterways. So over the 50 years, as I said, since the Clean Water Act, there's been a lot of development in terms of tools, mathematical models. There's been a lot of case studies of practices and how effective they have been in terms of mitigating pollution. So building on all of this knowledge, coming up with a quantitative analysis of the sources and then setting targets. Okay, so if we know that there's X amount of pounds of pollutant Y running in from the landscape, knowing what we know about the water body itself, its dilution capacity, the kind of ecosystem that's in there, how many pounds have to be reduced? What's an acceptable load? And how can we get there? So that's kind of the quantitative approach that the 9-element plan takes. So it provides the community, all of you, kind of some guidelines into, okay, if we need to make some changes, where are they most effective? And how are we going to get them done? Okay, and here are the 9 elements. This is just kind of a wonky slide here, but if you start looking at start on the left-hand side where it says quantify pollutant sources and inputs, these are, if you count up the boxes, there's actually 9 of, well, not the boxes, but the tasks, there's 9 of them all together. So quantify existing conditions, like look at the pollutants of concern and where they're coming from. Set your reduction goal. Like I said, how many pounds of pollutant X are acceptable to meet the water quality and habitat requirements? Then identify those best management practices. Look to what has worked elsewhere and see what's acceptable and appropriate for your particular community, right? Best management practices that are used on farms out in Iowa are probably not going to be immediately adaptable to the small scale farming in Madison County, for example. Then when you kind of have figured all of that out, you have to come up with a plan, schedule, where's the money going to come from? How are we going to measure progress? And then the adaptive management part, the monitoring and evaluation, have to also be included in the 9-element plan. So there's a lot of detail in that plan. And then overarching is kind of guidance and feedback from you, the community. There is one more thing, though, I want to say about the 9-element plan, and that is it's not a regulatory document. So as we together come up with a list of recommended actions, it does not require any person to take any specific action, right? This is just our collective best judgment about if we really want to get from where we are now to where we want to be, given the trends and things we can control and can't control. Here's a suite of actions that can get us there. So that's what the recommended actions are. They are not regulatory requirements. They are our best professional guidance and our kind of community acceptance of what could work for this particular landscape, and community here. Okay, that's enough for me. So I'm going to turn it over to, oh, no, I'm not. I have one more slide. So that's right. The where are we now question. So what we have in our plan so far, you'll see, we have talked about the watershed characteristics. You know, we've got maps and analyses and tables of the existing land cover. We've spoken with the assessor for the town of DeRuyter and, you know, kind of explored housing conditions and trends and, you know, what's happening with conversions and seasonal versus year round. And so we really tried to get a deep understanding of current conditions. And working with the Soil and Water Conservation District manager from Madison County, Steve Lorraine, talk more about what are the agricultural practices, the livestock count, the current cropping practices and such. And then fortunately, through UFI and the CSLAP program, we have good understanding of water quality conditions. This is a program that Barton and LaJudas has been working on for several years, like monitoring streams and trying to understand the sources of the stormwater running into the reservoir. And then we also looked at community initiatives, you know, in addition to the Preservation Foundation, the other partners. So, you know, the intermunicipal agreement that you have with the town of Cazenovia, for example, for the weed harvesting. Local laws, we looked at the town of DeRuyter codes, zoning codes and such. And then, of course, the state of infrastructure. You know, we can map the roads and ditches and then examine their condition as well. Okay. And here's what we found out about the land cover. This won't come as a surprise to you, I'm sure. The watershed is largely in forest cover. It's like 64% in this graph. Wetlands, a small amount of cropland, tiny fraction, less than 1% of hay and pasture, minimal developed area, and then a swath of open space too that is not in forest land, but is in scrub, shrub vegetation or recreational open lands. So that kind of set our stage for the current conditions in our analyses. And now I get to turn it over to the other Dave Matthews.
Thanks, Liz. So I'm going to talk to you a little bit about data. Any of these plans they're quantitative plans, so they're based on actual measurements made in the watershed, in the inflowing tributaries, and also in the reservoir itself. My colleague Monica has been working with volunteers, DeRuyter volunteers, to collect samples, make measurements of stream flow, to assess the biology in the 4 largest streams that flow into DeRuyter Reservoir. Did that in 2020 and 2021 and produced a couple of reports. I'm just going to hit some of the real highlights of those reports as they relate to the 9-element plan and maybe management of the watershed down the road. On the left here is a land cover map of the DeRuyter Reservoir watershed. It's color coded according to the land cover. So the greens are forest, the yellows and browns are some sort of agricultural production. I believe the brown may be cropland and the yellow is more pasture land cover. The 4 streams that were monitored are cut out there. The watersheds are in black. So moving from the northwest clockwise, there's input 1 that drains the northwestern portion of the watershed, input 19 down on the southwest side. just to the east of that, input 20. And then in the northeast corner is input 32. These four watersheds, as I mentioned, are the largest watersheds in the overall DeRuyter Reservoir watershed. And they drain kind of a diverse landscape. You can see that input 1 is entirely or almost entirely forested. Inputs 19 and 20 tend to have more agricultural land use, and input 32 is kind of mixed. It seems to have a little of everything. The other thing that's noteworthy about these watersheds is that the topography is quite diverse. So inputs 1 and 32 tend to have much steeper slopes, which we see on the east and west sides of the reservoir, more flatter lands where agriculture is more dominant down in the south. So to summarize our findings, what we found is that inputs 1 and 32 tend to be kind of sediment rich. More particulate matter flows off of those watersheds, consistent with the steeper topography. Inputs 19 and 20 tend to have higher dissolved nutrient concentrations. And when I say nutrients, I'm referring to phosphorus and nitrogen. We're concerned about those because dissolved nutrients are really what grows algae and harmful algal blooms in the lake. So those results are nice because they're kind of consistent with what we would expect looking at the land use and the steepness of the slopes around the lake. They also have implications for managing water quality. If sediment is a target, then maybe more focus on the steeper watersheds, 1 and 32 makes the most sense. If we're more concerned about primary production, algae, harmful algal blooms, then maybe a focus down in the southern watersheds makes more sense. Okay. All right, now we're going to move on and look at some of the in-lake data. And this data comes from the CSLAP program, the Citizen Statewide Lake Assessment Program. It's a volunteer program co-managed by New York State DEC and the New York State Federation of Lake Associations. I know Kathy's been super active in it for a long time. She walked by my office for years carrying in samples and we chat a little bit about DeRuyter. So the program is great. And I'll say I'm really invested in it because our lab has run the samples for over 20 years. But it monitors water quality conditions and allows us to establish a long-term record to see what has changed over time, which is really important when it comes to managing water quality. The program, particularly in recent years, has grown like crazy. I've lost track of the exact number, but I know there's over 180 lakes statewide in the program this year. And DeRuyter has been our super reliable lake. There are lakes that have shorter records or lakes that kind of come and go because, you know, it's a lot of work for the volunteers. But DeRuyter had a spotless record since 1988. So we have a wonderful long-term data set. And I do want to stress the importance of volunteers. The tributary data we have, the lake data we have, we wouldn't have it. We wouldn't have this long-term record without the hard work of volunteers pitching in. Okay, so we'll move on to looking at some of this actual data. So on the left are 3 plots moving from top to bottom. It's total phosphorus. The units are micrograms per liter, the same as parts per billion. Just below that is chlorophyll A. That is a pigment that's common to all algae. So you can think of it as a measure of how much algae is in the water. And then the bottom panel is Secchi disc transparency. That's how clear the water is. That's in meters. So meters about 3 feet. That tells you how far you can see a white and black disc down in the water. And, what we're taught is these 3 things are all indicators of the level of productivity or trophic state of the lake. And typically they all go up and down together. That's what I was taught in school. Derider's a little different. So if we look at the top panel, total phosphorus, we see that it varies some year to year. We have good years, bad years, and that's largely due to the weather, how much rain and runoff we get. But it has stayed largely between about 10 and 15 micrograms per liter. That's consistent with what we call a mesotrophic lake or an intermediate level of production. Chlorophyll, the middle panel, we see that beginning in the early 2000s, it really decreased pretty dramatically. The amount of algae in the lake went down. And then over the past, 10 years or so, it's been relatively flat. And Secchi disc transparency, clarity of the water has increased dramatically. Well, what's going on there? I thought these were all supposed to kind of track each other. Well, the best hypothesis is that those changes in the early 2000s were caused by zebra mussels and then by quagga mussels. They're excellent filterers of water, and they eat the algae, take it out of the water, make it clearer. And my guess is, although I don't have this, I haven't looked at this data, but probably plant growth, aquatic plants increased about that time. Water is clear, they're getting more light, they grow denser and into deeper water. So the panel on the right shows the 3-year rolling average of total phosphorus. Again, we see some ups and downs. Recently, we've been averaging just a little over 12 micrograms per liter. And so we're kind of using that statistic as a goal here. And the vertical bar, the blue vertical dash bar is 12 micrograms per liter, thinking that, well, in the future, if we could hold the line, if we can keep it there, despite things like climate change, which are going to tend to move it higher, despite the next invasive species, who knows what that'll be, that if we can maintain this water quality into the future, that would be a reasonable goal. So with that, I will turn it back to Dave H.
Thanks, Dave. All right, so I'm going to talk a little bit now, as Dave really went through what is the water quality within the lake. As far as the 9-element plan, we're really focusing on the watershed, what's going on outside of the lake, looking at the contributing land uses and activities within the watershed and how that ultimately affects water quality within the lake. So the way that we did this was through a tool called Model My Watershed. It's a web-based modeling program. And we looked at primarily the phosphorus loads. The model looks at phosphorus, nitrogen, and sediment. But the 9-element plan is really focused around phosphorus. And we looked at how much phosphorus is coming off the watershed. It's over 2,000 acre watershed. How much is coming off the watershed today based on the current land use? And then we also looked at how much phosphorus could come off the watershed in future years, and what could those changes be? Those changes could be more rainfall. We've all seen more intense storm events, higher quantities of rain over a short amount of time. How does that affect the phosphorus loading to the lake? Also, what about land use changes? As Liz mentioned, anything from conversions from seasonal to full-time houses, or perhaps new housing going in within the watershed, or changes in agricultural practices, how does that affect the phosphorus loading? And really the goal of this, you'll see us mention this a couple times, is trying to build resiliency within the watershed, hydraulic resiliency within the watershed. So what have we found? Through the modeling, for existing conditions, so today, based on the watershed characteristics, there's about 515 pounds of phosphorus rolling off the watershed every year going into the reservoir. So this table indicates the different sources. The big drivers of phosphorus are agricultural activities, croplands, also open lands that are not in agricultural use right now. There still is a phosphorus source from those open lands. Subsurface base flow is another high contributor. And what that is, that's phosphorus that is coming into the reservoir either through groundwater or through base flow in the channels in the tributaries to the reservoir. And then the last row you'll see are septic system influences, which are a big driver of phosphorus loading. Yes, that's on the bottom. So 142 pounds per year out of the 515. So what about the future? The way we analyze this is we increase the precipitation value that goes into the model. So we looked at storm events roughly from 2 inches to 5.5 inches, and we increased the volume of that rainfall by 15%. So basically we increased the runoff, the amount of rain by 15%. And the purpose of that is to take into consideration climate change impacts and more intense storms. And what we saw is that 515 pounds of phosphorus that we see today would be anticipated to go up to just over 600 pounds of phosphorus. So it's an additional 86 pounds of phosphorus per year. And as I mentioned earlier, some of the greatest sources of phosphorus loading, again, agricultural activities, septic systems, and that subsurface base flow, those contributions through the base flow of the tributaries or groundwater. And today, it's modeled at 515 pounds per year. And with that climate change impact, we're seeing roughly a 16.5% increase in potential phosphorus loading to the lake, to the reservoir. So our initiative right now, kind of the goal that we've set and we want your feedback on, is we want to maintain the hydrologic resilience of the watershed, taking into account what we expect to be a changing climate, more intense rainstorms, heavier rainfalls, and we want to, at a minimum, maintain the baseline phosphorus loading to the lake. So what that means is we need to develop a plan, to develop management practices to reduce at least 16.5% of the increased phosphorus loading associated with the changing climate. And that would kind of keep us at our baseline today. Make sense? Yes.
Does the fact that the lake, the lake goes down the fall, I mean, we rid ourselves of water, okay? Now, I don't know where the phosphorus resides in the water, but does that do any cleansing of the lake, if you will?
Yes, I'm just going to repeat the question for the folks online. How does the turnover of the lake as the lake draws down, how does that affect the phosphorus? And does that phosphorus leave the lake during those turnover events? Liz, do you want to speak to that, or?
I'm happy to jump in.
Is that an advantage or is it
Well-
a non-factor?
It's an advantage. It could be an advantage. It's an advantage if the water from the tributaries that you're renewing the lake with, if that load goes down over time, it's an advantage. So the flushing rate, see if I get this right, is it once every 4 years? Is that the estimated residence time of the lake? That's about average. We deal with lakes that have residence times of 15 or 20 years. So that means if they made a change in the watershed, it's going to take decades to see that reflected in improved water quality. In DeRuyter, we'll see that in a much quicker period of time. But again, it assumes that we get that reduction in loading from, kind of more contemporary discharge to the lake.
And if we concentrate on going forward, making sure that every new septic system that goes in is a little bit more efficient in terms of not putting phosphorus into the lake. Is that a big factor?
Well, it's a factor, right? So I think that was what, 142 out of roughly 500. So it's significant. Yeah, for sure. And it's a manageable thing. Some of these things are harder to manage. That's something we understand, right? And we do have control over. So yeah, that would be a recommended practice for sure.
And that 142 pounds is spread over 300 plus septic systems throughout the watershed. And that varies on the location of the septic system within the watershed. Is it near lake? Is it further away from the lake? Yes. There's some de minimis influence there could be.
That phosphorus is still improperly operating.
It's a mix. It's a mix of both, but definitely a higher driver from improper systems. All right, so as I mentioned, the 9-element plan, I still want to lose focus here, is based on looking at practices outside in the watershed, outside of the lake. But of course, all this leads back to the phosphorus loading and the water quality characteristics. So the in-lake goal of phosphorus, we've targeted at 12 micrograms per liter. And as Dave mentioned earlier, that's a little bit below the current 3-year rolling average of 12.5 micrograms per liter. So how do we get there? And this is where we're at right now in development of the 9-element plan. We need to identify feasible and fundable mitigation alternatives. And that's where we want your input. So it's our role to identify a suite of best management practices that can help us, knock out 17% of the phosphorus loading within the watershed. That's the first thing, is to identify what needs to be done. The second thing is, where does the money come from? So the 9-element plan will include recommendations and resources to fund the practices that we recommend. And third, who are the stakeholders and agencies that will be involved with this process? One of the first few slides showed all the various agencies, different funding sources, but there's a lot of different stakeholders and opportunities for improvement to meet our goals. So we're going to shift gears and talk about some of the public feedback that we've received
Hey, Dave.
to date. At the bottom of the
Dave.
screen, you'll see the foundation's website. And at that website, there are 2 tools that you can use. There's an interactive mapper and a community survey. And we introduced these tools during our first public meeting last November. They are still on the website. They're still active. So if this discussion creates thoughts and you want to add to the survey or add to the mapper, if that's still an option, you can still do that. But this is what we've heard so far. We got pretty good feedback. Almost 140 people responded to the survey, And I'm just going to go through this pretty quickly. As I mentioned earlier, the presentation will be saved to the foundation's website. But one of the questions of what's your interest in the lake? As you can imagine, most people that responded are residents that have lake access or live within the watershed. Also, we did get some input from the agricultural community as well. Up top, what are your primary uses of the lake? Not surprisingly, boating, swimming, aesthetics, fishing were the big drivers there. We asked the question, what areas of the watershed show the greatest need for improvement? And the feedback we received are contributing streams. So the erosion from the different inputs, there's 34 inputs into the lake that are shown up on the board up here. Each of those inputs has varying levels of erosion that contribute sediment, gravel deposits, and phosphorus into the lake. We also had notes on in-lake concerns, shoreline areas, needs to improve wetlands and conservation areas as well. That could include HAB control, harmful algae bloom control. It could include weed management, excessive growth. It was an open-ended question. So we asked rank the top 3 primary threats that you see to water quality. And you'll see the biggest comment that we received back was septic contributions, followed pretty closely by agricultural impacts, and then by ditch and channel erosion. Those were the public's perception of the 3 biggest threats to the reservoir. Then we asked, rank your 3 primary concerns for lake protection. The number 1 concern from the respondents were harmful algae blooms, followed by invasive species and excessive vegetation or weed growth. We asked, what types of lake improvement projects would you prioritize? Invasive species management was the driver for that. We also had a lot of interest in-lake vegetative harvesting, agricultural best management practices, again, septic management. And then if you look at the bottom, you could kind of combine those 2 bottom rows for either stream bank stabilization or roadside ditch stabilization. We asked the question, do you feel the need that there's a need for more public education and public involvement? The vast majority of respondents said yes. And then finally, this was just a general perception. What's your perception of the reservoir, of the water quality? Is it improving, degrading, or remaining about the same? Most people said remaining the same, kind of a split between remaining the same and degrading. And some people thought water quality was improving. So we also have this interactive mapper on the website. Again, this is still open. And what this screenshot depicts are all of the different areas of feedback that we received from the community. So each one of these dots on the map, someone made a note and identified an area of concern. And a lot of those dots overlap. So there's quite a bit of input on
Septic discharge or something?
septic system surface discharge. That was just one option that people could put as an. It would be, yeah, it would be a failing septic system. So what did we get back? Most respondents came back with, you can see that the gray bar here is sediment or gravel deposits, and that's directly also tied to the excessive erosion. So we got a lot of comments on the erosivity of the roadside channels and the different inputs into the lake. We also got a lot of comments on areas where people observed algae blooms, this row here, or excessive lake vegetation right in the middle here. So again, you can go onto the website. You can click any one of these icons and you can see what people put down. So these are, you know, our neighbors, are the folks that live within the watershed, and you can create a discussion revolving around those different comments. Some people added pictures. There's a lot of good information there. All right, so where are we going? And most importantly, where do we want to be? So the project team spent a fair amount of time discussing a vision statement for the reservoir and for the 9-element plan. And I'm going to read that out now. So this is what we want. We want the DeRuyter Reservoir watershed is a healthy and resilient ecosystem that provides clean water, habitat for a diverse assemblage of terrestrial and aquatic native species, recreational opportunities, economic benefits, and aesthetic enjoyment for current and future generations. Realization of this vision requires the sustained actions of the Tioughnioga Lake Preservation Foundation and other stakeholders to manage the lake and its watershed. That's the goal. We all in favor? All right. So we've developed this model that has looked at existing conditions. We've looked at potential changing conditions associated with climate change. And our next step is our project team is to come up with different practices that can help offset this increased phosphorus loading. Once we do that, we'll plug those practices into the model, see what benefits they provide, and our goal will be to meet the reduction goals that we've targeted. So some of the initial practices that we've identified are stream bank and road ditch stabilization, implementation of additional agricultural best management practices, stormwater retrofits and detention. And what that means, that could be building a stormwater pond in the upper watershed to control the flow that's coming into the lake inputs. Looking at opportunities to enhance riparian buffers in floodplains, creating new wetlands within the watershed, capturing and infiltrating stormwater. A lot of times we refer to that as green infrastructure. So the intent of the green infrastructure project is to capture rainwater at the source and allow it to infiltrate into the ground, as opposed to running off and potentially picking up nutrients and sediment. And then also, of course, household waste system management, septic system maintenance. So where are we going? We kicked this off last November with just kind of a project introduction meeting. It's hard to believe we're in June already. I don't know what happened, but here we are in June. We have done a lot of work on the modeling side. We've identified some target goals. We've conceptualized some practices and some means and methods to meet those reduction goals. And we've started to develop the framework of this 9-element plan. For the course of the rest of the summer, we're going to meet again August 30th, Joan? 31st. There will be plenty of notice prior to that next meeting. But at that next meeting, we are going to have a fully drafted 9-element plan. And that 9-element plan will include our recommendations for how we will meet these pollutant reduction goals. It will also include a proposed schedule for implementation, milestones, opportunities for funding, and ways to measure and evaluate the success of the 9-element plan. So that's going to be August 31st. We're likely going to move that to a night meeting, early evening. It will either be here or maybe at the boathouse. We're not sure yet. But again, there will be plenty of advance notice and advertisement of that next meeting. So when we meet next, we're gonna present the draft plan. We're not gonna solidify that plan until after our next meeting. We want more input. At that point, the plan will be posted to the foundation's website, and we can take comments on that plan. And then, our goal is to finalize the 9-element plan early this fall. Then once we're done, the plan will be submitted to the New York State Department of Environmental Conservation. They will review, comment, and then we'll work towards getting an approved 9-element plan that's been approved by the New York State DEC. And what that really does is it opens the community, the watershed, to additional funding sources. It creates a higher priority for funding, for money to come into the watershed to implement these projects. I'm just gonna throw these slides up here, some contact information from the foundation. Joan, Keith, and Kathleen's emails are up there. And then our project team, the three of us sitting up front. This is our contact information. And again, I'll point you to the bottom of the screen here. The website, that mapper is still available. The survey is still available. So there's still time to put your information there as well. All right, well, I thank everyone online for joining us. Again, go to the website, please. There's more opportunities to do the survey, to do the mapper, and we'll meet again in August.